Thank you very much for having me. You cannot imagine how excited I am to be here today. It's fine that the slide is black. It's all good. Hello, everyone, as well to everyone who's watching remotely. I hope you're enjoying the conference. Before I'm going to introduce myself, I want to show you some small snippets of code and ask you one simple question. Does this look like fun to you? When we take a look at this, it looks innocent enough. So we push it to production, run our code, and run into this beautiful runtime error. Uncaught reference error, root is not defined. Of course, those runtime errors always show us the little line where the error happened in our code. So easy enough, we can spot that we just made a small little typo there. So, of course, we fix the typo, call it a day, push the code to production, go into the weekend, and, of course, Saturday morning, the client calls and tells us it's still not working. We ran into another runtime error. Errors like these are exactly the reason why TypeScript has risen in popularity over the last couple of years. Because, of course, the main promise is those type of problems and errors will never appear at runtime if you're working with TypeScript. So you're going to your tech lead and convince him to convert, you migrate your complete code base all the way to TypeScript. Because maybe it's an older project, we're still working with class components, and we're even using legacy APIs like the legacy string refs. So as you can see, this is already TypeScript code, but there's still the same runtime error. Here we are passing a string ref down there to the div to get a reference to the HTML node, and at the string root, and we access this at the top with this.refs.root, but again with the same typo. So as you can see, only because we are using TypeScript, it does not guarantee that we will not run in any runtime errors. It depends on the framework, it depends on the APIs that we are using, how safe we really are. And this is exactly the topic of my talk that I'm going to give to you now. How typed is React really, and how does it compare to other frameworks? But first, I'm going to introduce myself because I guess most of you won't know me. My name is Andreas, and I'm from Dresden in Germany, and I'm a development lead at a small agency. And something around 2016, we started off migrating our first project to TypeScript, and since then, we have been great fans. So every new project that we are starting, no way we are starting with JavaScript, it has to be TypeScript, or else we are out. And I guess many of you, or some of you, are sharing a similar journey. And this rise in popularity has led many of the popular frameworks to add a sentence like this to their documentation. We offer first-class TypeScript support. TypeScript is working out of the box. The TypeScript is a first-class citizen in our framework. Funnily enough, maybe you saw it already. Yesterday, they released the newest version of the React documentation as an early beta. And I searched the docs, and so far, nothing like that is in the beta documentation, but we will see. Maybe it will be added at a later point in time. When we take a look at the popular frameworks, a lot has changed over the last previous years. First of all, Vue.js, when they announced Vue 3.0, they announced that they have completely rewritten the framework based on TypeScript, and they are able to offer a much better experience than with the earlier versions of Vue. Angular as well, even if they started with TypeScript all those years ago, they started actually so early with TypeScript that TypeScript was not yet powerful enough to model all those dynamic features that the framework needs to offer its users. Sadly, on the React front, things have been a bit stagnating. But this is not a problem at all, because from the beginning, when TypeScript made the decision to directly support JSX or TSX, we never had any problems with the TypeScript support. So on that front, even if not much has changed, we can still get the benefits of TypeScript in our language. In the following, I want to take a look at different areas of the framework that can be supported by the framework. At first, we're going to take a look at the basics. So within one component, you have this logic part where you call functions, you define variables, and you pass these logic parts to the template, and this template is then accessing those variables. But this is only the basics. So it's the lowest level of TypeScript support that a framework can offer. the minimum requirement to really be able to help us as developers is when the boundaries between components are typed as well. So the inputs, the data that is flowing into our components, and the output, the events that flow out of it, they have to be type safe as well to really bring us any benefits. But let's start with the basics. First, maybe we are not even working with TypeScript, maybe we're still working with JavaScript. TypeScript can already help us in our framework of choice. Here, maybe we installed the React type definitions into our project. So when we type react.use, we get an autocomplete, we get suggestions of which functions we want to use right there. Later, we migrate our project, and then we're still in the logic part of our component, but already here, the TypeScript can support us and help us and show us errors when we made a small little typo or used a function that does not exist. When we then want to use this data, this logic in our templates, TypeScript again wants to help us. So here we define some number, and we want to use it in the UI, in the template part. And here as well, TypeScript can help us and give us the right suggestions. And as you see on the right, when we access the function that does not exist, again, we see the error in the editor. One very important part is that we don't only want to see the error in our editor, because when we write code, maybe we are too fast for TypeScript in the background when it's compiling. Sometimes it takes a bit. Maybe you already closed your file, pushed to production or pushed to your pipeline, and then we want to be able to crash the pipeline if we still have typo errors in our project. So the framework has to offer a possibility so that we can run the type checks with a command line tool. Luckily, because TypeScript directly supports JSX, we can just run TSC, the TypeScript compiler, and have the errors crash the build pipeline. In the next step, it can get a bit more complex when we want to use more features that TypeScript is offering us. Like right here, we have our component that receives as a prop a value x, which is either a number or a string. So of course, we cannot be sure which we got in our use case. So when we directly call the toFixed function on x, TypeScript can offer us this helpful error and tell us it's all good that toFixed exists on a number, but on the type string, the function toFixed does not exist. So TypeScript forces us to first check if the variable x really is a number, and only then can we access the functions that exist on numbers. This is a feature that has only been added to the other frameworks quite late, actually. For example, here we are seeing the equivalent Vue.js code. We have basically the same thing, defining a property that is either a number or a string, and we're using it in the template. And we're getting exactly the same error as earlier, because Vue.js, they found a possibility to compile the templates into real TypeScript code and have the same kinds of errors that we get natively by the TypeScript compiler in React. Now we have the basics down, so we can define the logic of our components in a type-safe manner. We can access this logic in our templates and have TypeScript help us all the way. Now let's jump into the boundaries between components. Like right here, we have our component B, which receives as an input a value x as a number, and it provides an output, which is again a number. When we're now using that component on the right, of course, we want to make sure that we are using this component correctly. So right here, we are passing in a string instead of a number. TypeScript can help us there. Same thing with the outputs. We defined that setX is always called with a number. So there again, we get the help from TypeScript. A very interesting thing is that these kinds of errors are not supported in all major frameworks. For us React developers, it's quite natural that if we define two properties, x and setx, then we have to provide these when using the component, but this is not a given in all other frameworks. Now we have the basics down, and as I said earlier, especially since the latest changes in the other frameworks, they have really caught up with React on that regard. But there are still some cherries on top that React is offering us that the others can't or cannot quite easily give us as developers. First of all, the great thing about React is that components are just functions. It's, as the documentation says, it's just JavaScript. It's beautifully simply. Like right here, we have our button component. Maybe it's even from a library where we have typed props. The problem is maybe this library does not export this interface as an explicit type, but it only exports the component. But because in TypeScript, in React, the components are simple functions, we can use TypeScript helpers to access the shape of this argument. We can just use the parameters type, extract the interface, and extract the type of the button function, and the parameters type will return to us a list of all parameters that our function expects. So right here in our example, a React component always receives one argument, the props object, so we use index 0 to extract the props of our button component. So just because the library author decided to not directly export the type of the button component, we can still access it with parameters. However, right now, this only works with function components, but luckily, the React type definitions export a helper type called component props that we can use to access the props of function components, of class components, and of the built-in HTML elements. So for example, right here, we are extracting all properties that the native HTML element is allowed to receive. This is very useful to define very thin wrappers around other components. For example, right here, we want a small wrapper around the HTML button component where we are able to pass in another property, an icon. So we are just extracting all properties from the HTML button element and joining with the intersection operator, joining some new properties, like here, the optional icon prop. In our component, we can then just destructure our props, pass in the icon and use it in our component some way or another, and pass in the rest props down to the button. And the nice thing is that if for some reason HTML adds another property to the HTML button, this still works and is still completely type-safe. So we don't have to repeat all props that are present on the HTML button, but can just take the props from the HTML button and join them into our prop types. We can also leverage this pattern to exchange components in our applications in a type-safe way. So here, for example, we have this customizable application. There we are defining as an argument we want to receive any component that fulfills the interface of our button component. This way, we could build a framework where the buttons are themable, exchangeable, have different behavior, and users of our framework can just supply their own button component, which will be used everywhere in the application. And we still have this in a type-safe way. So they have to make sure that their button component complies with the interface of this button props element. Next, we want to take a look at another great feature that we receive by having the components being only functions. Maybe you heard the talk earlier about virtualization. Virtualization is the technique where you don't want to render all elements in a list, but only the elements that are currently visible on the screen. And here, we are building a small dummy component that is doing exactly that. We define the interface here with receiving an item count and an item height. This makes calculation quite easy, which elements are currently visible in the viewport. And we pass in a render item, render prop, which we can use to define how each element is being rendered in the UI. Of course, we then have to make some calculations to calculate which elements are currently visible. We're going to skip that for now. And then we are just iterating over the visible indices and call the render prop. When using this component, it looks currently something like that. So we fetch some data. It's a person array in our use case. And we want to use our virtualized list to render those persons to the UI. Here, because we defined that the index of render item will always pass out a number, we are working in a type-safe way. So we're accessing an index on the persons list and accessing the field name or age. The problem is that maybe we don't always have a list available. Maybe it's a lazy loading list where we just fetch the data on scroll. It's an infinite loading list, for example. So maybe we don't have an array where we have all persons available. So optimally, we want the API to look like this. Render item now gives us a person object. And on a person, we can access name and age and no other fields because only these two exist. The problem is, when thinking about this naively, we might think that we now have to develop a virtualized list for persons, a virtualized list component for cars, a list component for pets, etc. And of course, this cannot be the right solution. So maybe at first, we are changing the interface of our virtualized list component to receive unknowns or any props. This way, when using this component, you can pass in a list of persons, a list of cats, a list of animals, and it will work. The problem is, on the output side of things, render item will pass us an item element of the type unknown. So we cannot use it to access the fields age and name because unknown does not have any fields. So now we would need some kind of a contract that we can use to connect these two unknown properties. And for this, we can use TypeScript generics. So we define this t-item generic type variable that we can then use to define that items is of any type with t-item array. And when used with the type person, for example, then we want render item to give us back a person again. So when using this component, we can pass in a list of persons, and TypeScript will know that we instantiated the component with the person type, and we will receive the person object in the render item function. When we hover over this JSX element, we get this tooltip where we can see that TypeScript correctly inferred the type of our component. This way, we can build a component that can be used with different kinds of types, so with persons, cats, cars, whatever, and while still being completely type safe when using this component. Another quite popular pattern that is using this feature is the as-prop. Maybe you've used it in styled components or emotion, where you can pass in another component in the as-prop and want to pass in new properties to this new generic component. So like right here, we have this link component, which normally renders just an A tag maybe in the UI. But right now, we want to render it as a button element, and we want to be able to pass in an additional icon. And here, again, we can make use of the TypeScript generics and define our component like that. You can see maybe one of the problems when working with TypeScript a lot, the component code, the library code starts to look quite complex, but we are achieving a very nice usability for the users of our component. Like right here, for example, we define the type variable t-component. We add this constraint that it has to be a component type. And then we can say that our link component will receive the as-prop, where we can pass in any component, and it can receive all props that this passed component wants to receive in the UI. So now I hope that you could see that, yes, TypeScript support is good, and all frameworks have the basics down of this TypeScript support, but TypeScript support is more than only defining the types inside of our logic of our component, inside of our templates, also on the boundaries between components, but also there are lots and lots of additional use cases where we can leverage TypeScript in our React projects. I want to say thank you for listening to my talk. I hope that you have some quite exciting questions for me right now. I wish you a lot of fun at the remaining conference and want to say thank you.